Yeah. Here in this, we will be discussing about the all process concepts. Okay. What is process? Before starting for going for the process concepts, what is process we'll be studying here. What is process? We have discussed, I think, previous chapters. I also we have referred the word called process. Process is nothing but program in execution. Okay, program in execution is called as process. Okay, and the process needs some certain resources to do its task. Okay, what will be the resources? The resources will be like CPU time, memory, files, IO devices, all the resources used by the process to accomplish its task. Okay, to perform the job, the process will use the resources. Okay, and these resources are allocated to the process either when it is created or while it is executing. Okay, resources will be allocated to the process when the process creation itself or when the process is executing time. Also these resources will be allocated to the process. Whenever the process needs the resources, that time the resources will be allocated. Okay, here process is what? Basically it is a program in execution. Here the execution of process must progress in a fashion, sequential manner. Execution of process will be in sequential manner. Okay, and the process is defined as entity which represents the basic unit of work to be implemented in the system. Okay, process also can be defined as an entity which represents the basic unit of work. Unit of work will be represented as a process. Process represents a basic unit of work. Okay, we can say the basic unit of work is nothing but the program. Okay, and which to be implemented in the system, executed in the system, is called a process. Okay, in normal general terms, we define the process as process is nothing but a program in execution. We call it as process. And in this textbook, they have referred job and process almost interchangeably. Wherever we say process, sometimes we refer job. Job is nothing but process. Process is nothing but the job. Okay, it is program under execution is called process. That's what we need to remember here. Program is process is a program in execution is called process. Okay, and process is more than the program code, which is also called as text section. Okay, it is not just the program. Process is not just the program. Program in execution is called the process. Okay, so the process is more than the program code. Okay, and which is also called as text section. Okay, here the process will it contains the program counter. Okay, process will contains the program counter, it contains the stack, it contains the data section. Okay, here the program counter which represents the current activity, and also it contents of the processor's registers. Okay, the program counter which represents the current activity, and process also contents of the processor registers it will be having it. Okay, and process also includes the process stack. Okay, process will also includes stack, process stack. Okay, process includes the program counter, and process include that program counter, what it will do, it represents the current activity. Okay, and process also includes the stack. The process stack contains the temporary data such as like methods or function parameters or return address or local variables. This will be holded by the stack here. Okay, process includes the program counter, process includes the stack. Okay, process include the program counter. What the program counter will do, which represents the current activity. Okay, which it will be the state of the process. Okay, what is the process ID? All that will be represented by the program counter. And the process also includes the process stack. Okay, the process stack consists of the temporary data like return address, methods, or functions parameters. Okay, local variables will be holded by the stack. Okay, next process also includes the data section. Okay, the data section which contains the global variables. Data sections will consist of global variables. We can see the process structure, the processing memory. Okay, we can have the stack, it will have the program counter, it will have the data section. Okay, and the process may also include the heap. You can see here, the process may also include the heap. Okay, which is a memory that is dynamically allocated during the process runtime. Okay, heap is a memory that is dynamically allocated during the process runtime. Okay, this is the structure of the process. What the process is? Process is nothing but program in execution. What the process consists of? Process consists of the program counter, process consists of stack, process consists of data section, and process consists of heap also. Okay, what the program counter will represent? Program counter will represent the current activity. Okay, and process stack will consist of temporary data like methods or functions, parameters will be there, return type will be, return address will be stored, and local variables will be held by the process stack here. Next, we process consists of data section. Data section consists of the global variables. Okay, and the process may also consist of the heap. Okay, that means which is a memory that is dynamically allocated during process runtime. Understood, right? This is about process. Okay, process in memory will look like this. Okay, we have discussed what is process, what the process includes. Process includes program counter, process stack, data section, and heap. Okay, understood, right? Next, we'll discuss the process state. Very, very, very important concept it is. Okay, usually, it will be asked in the video exams. Here, as process executes, it will changes its state. Okay, that a process will change from its one state to another state. Okay, like we have the different process states, that is new, running, waiting, ready, and terminated. Okay, these are the different process states. When the process is executing, the process will change from one state to other states. Okay, one state to another state. We can see here in the diagram, you can see here. Okay, this is the process state diagram. Very, very important. Here it is process states will be represented by the vowel symbol only, and state transition will be represented by using the arrow mark. Okay, and here events will be written here, because an occurrence of an event, process will change from one state to other state. Okay, and each process may be in any one of the state. Okay, whether a process can be in the new state, a ready state, or waiting state, or running state, or terminated state. Process must be in any one of its state. Okay, and while executing, the process will change its state from one state to another state. Okay, first we'll see the new state. Okay, you can see here the new state. This is the process is being created. Okay, once the process being created, the process will be in this new state. Okay, then we have here uh, ready state. Ready state is the process is waiting to be assigned to the process. Okay, if the process is waiting to be assigned to the processor, the process will be in the ready state. Okay, it is already, process is already created and it is in ready to execute it. That process will be stored in the ready state. Okay, in ready state, process is waiting to be assigned to processor. Okay, it will be waiting for the CPU time. That's what you need to understand here. When the process is created, it will be in the ready new state. After that, it will be shifted to the ready state. That means that time the process will be loaded to the memory and waiting for CPU to get executed. Okay, it will be waiting for, process is waiting to be assigned to a processor. That is ready state. Understood, right? Next we have running state. Okay, running state is instructions are being executed. Okay, whatever process is, process execution state is nothing but running state. Here the process will be executed in this state. Okay, next we have waiting state. Okay, waiting state is the process is waiting for some event to occur, is called waiting state. Process will be waiting to, waiting for some event to be occur. That is waiting state. Okay, so process can from the running state, process will come to waiting state for some any event to occur. That event may be some IO event or uh, any the process may want some any IO devices to complete its execution. Okay, for any IO resources, the process will shift from, transfer from running state to waiting state. Okay, waiting state is nothing but the process is waiting for some event to occur. Okay, here the event can be, it is like a IO completion or reception of some signal. Okay, it may be waiting for some signal to happen. Okay, from waiting state, the process will excuse me. Yeah, once the IO request is completed, okay, once the waiting time is completed, when it got some event for what it is waiting, then the process will shift from, transfer from waiting state to ready state. Once it go back to the ready state, again it will be waiting for process to assign. Okay, to execute the process. Okay, a process will be waiting for processor to assign. Okay, a ready state process is waiting to be assigned to a processor, is ready state. Okay, new state, ready state, running state, waiting state. Next we have another state called terminated state. Okay, terminated state is nothing but the process has finished its execution. Once execution is completed, the process will transfer from running state to terminated state. Okay, this is the process diagram. Understand carefully here. Once it is, when the process is created, new process, newborn process, whatever newly created process will be in this new state. Okay, new state is the process is being created. Okay, that time the process will be in this new state. Okay, then after that it will be transferred to the ready state for execution purpose. Okay, in ready state, process will be like process will be waiting for processor to get assigned. Okay, to execute the process. Okay, next, once the from the ready state, the process will be shifted to the running state by using some scheduler dispatch or scheduler algorithms. By using the algorithm, CPU will be allocated for the process. Okay, ready state, there can be many processes. Okay, that time the which process should be shifted transferred from the ready state to running state, that will be depends on the scheduling algorithms. Okay, after that the process will transfer to ready state to the running state. Running state is nothing but this is the place where the process is waiting to be assigned to the assigned to the processor is ready state. Okay, running state is where the instructions are being executed, that is nothing but where the process is executing is this place is called running state. Okay, from running state also process can be transferred to the ready state. Okay, but by if it might have got any interrupt or sometime, that time the running state to ready state the process will get transferred. Okay, because of some event occurred, the process will change its running state to ready state. Once again the process shifted to the ready state, it will be waiting for another it will be waiting for processor to get assigned for it, that to execute it. Again from ready state to running state the process will uh, transfer. Okay, sometimes the from the ready state the process may need some resources to complete its execution. That time the process will shift from ready running state to the waiting state. Okay, with some IO request or something, it will shift from running state to waiting state. Once that IO request is completed, again from waiting state to ready state the process will be transferred. Okay, once again the process is in waiting state means it will be again waiting for processor to be assigned for this process. Once the processor assigned by using the scheduling algorithms, the process will transfer to the ready state to the running state. Okay, after completion of execution, the process will change its state from running state to the terminated state. Okay, this is nothing but exit. By using the exit event, the process will change its state from running state to terminated state. Understood, right? Only one process can be running on any processor at any instant. Okay, only one process can be running on any processor at any instant. Okay, a processor can run only one process at any instant. Okay, many processes may be ready and it can be waiting for the processor. Okay, when one process is executing here, all other process should be in any one of these state. It can be in the new state, some process will be there, some process ready state, some process will be there, waiting state, some process will be there, terminated state, some process will be there. Okay, this is about process state. Okay, process executes when as the process is executes, it changes its state from one state to another state. Okay, and each process may be in one of these any one of this state, whether the process can be in the new state, ready state, running state, or waiting state, or terminated state. Understood, right? About each state. First state is new state. New state is nothing but the process being created. Okay, next ready state, the process is waiting to be assigned to the processor. Okay, next running state, here the instructions are being executed is running state. Next is waiting state. Waiting state where the process is waiting for some event to occur. Okay, that time process will be in this waiting state. Okay, next state we have here is terminated state. Once the process has finished its execution, process will be shifted to terminated state. This is about process state. Okay, next concept here is process control block, PCB. Okay, it will in short form it is called as PCB. In this textbook, in many places we refer instead of process control block, we'll be saying as PCB. PCB stands for process control block. Okay, a process in an operating system is represented by the data structure known as process control block. Okay, so what the process control block will represent? Okay, a process in the operating system is represented by the process control block. Okay, and it is also called as task control block. Process control block is also called as task control block. Okay, the information associated with each process is the process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, and IO status information. Okay, the process control block will be, it is nothing but the process control block will be like it serves as a repository of information. Okay, that may vary from process to process. It's a repository of information about process information, repository of process information it is. Okay, each process will have this information like process state. You can see here the process control block will look like this. Okay, so the first one here is process state. Process state is nothing but the current state of the process, which represents the current state of the process information will be stored in process state. Okay, process control block will hold the all these information: process state, process number, program counter, registers, memory limit, list of open files. All these things will be hold information will be stored by the process control block. Okay, here the process state is nothing but the current state of the process, whether it is the process is in ready state, or process is in running state, or process is in waiting state, or process is in halt state. Okay, this will be represented by the process state. Okay, next we have the program counter, process number also. Every process will be identified by using a process identifier. Process ID will be there. Whenever the process will be created, that ID will be assigned to that process. Okay, that process ID also will be stored in the process control block. Okay, next program counter. Here the program counter includes the address of the next instruction to be executed for the process. Okay, remember here what the program counter holds. It indicates the address of the next instruction to be executed for the process is program counter. Okay, program counter indicates the address of next instruction to be executed for a process. Next is CPU registers. CPU registers, the registers vary in numbers and types here. Okay, and it is depends on the computer architecture. Okay, CPU registers will be different for the different computer architecture, different number for the different computer architecture, different type of CPU registers for the different computer architecture. Okay, along with program counter, the state information should be saved to allow the process to be continued correctly after an interrupt occurs. Okay, if an interrupt occurs, this address of these registers also will be stored in this process control block. Okay, I will explain you while discussing that interprocess communication and all. Okay, next is CPU scheduling information. Okay, this CPU scheduling information includes the process priority. Okay, pointers to scheduling queues or any other scheduling parameters will be in this CPU scheduling information. This process control block will hold this information also. CPU scheduling information also will be held by this. Okay, next one is memory management information. Memory management information, this information may include the value of base and limit registers or page table information, segment table information. Okay, depending on the memory system used by the operating system. Okay, that memory management information will be held by this. We'll discuss in detail about this memory management information when we are studying the memory management module. Okay, next is accounting information. Accounting information is, this information includes the amount of CPU or real time used or time limits or account numbers, job or process numbers, all is nothing but accounting information. Okay, that also will be holded by the process control block. Next one is IO status. Okay, this IO status is this information is excuse me. The IO status information includes the list of IO devices allocated to the process or a list of open files. All this information will be holded by the process control block. Okay, so this process control block will serve as a repository of information. Okay, that may vary from one process to another process. Okay, what information the process control block consists also, it depends on one process to other process, it will be different, but these are the basic information which will be holded by the process control block. Okay, it serves as a repository of information. Okay, process state means it is nothing but what state the process is. Okay, current state, process current state will be holded by this process control block. And program counter. Program counter, this program counter indicates the address of the next instruction to be executed for the process. Okay, we'll see how CPU registers. Yeah, you can see here CPU switch from one process to other process. Here the process 0 is running here and process 1 is running and it is waiting for CPU's resource. Okay, so when it is executing the process 0, it got an interrupt. So that time what the CPU will do, it will with this interrupt or system call, it saves the state of the uh, program counter. Okay, it will stores the process control block. It saves the state of that process into the process control block 0. That is nothing but it's a process control block 0 is process P0's process control block. Okay, from when it is leaving, the processor is leaving, that time it stores that where the execution has been stopped. That information is stored in the saved into the process control block 0. Okay, then it will load the state information from process control block of 1, that is process P1's information. Okay, it loads the process P1's information and then it will start executing the process P1. After completion of that interrupt execution, again it will save the state information of the state information to the process control block B1. Okay, that is process control block 1's process information will be stored to the process control block 1, that is process P1's information will be saved to the process control block of process P1. Okay, then again reloads the state information from the process control block 0. Okay, here before going for serving the interrupt, we have saved the process information in process control block 0. That information we are reloading it from the process control block. Then by seeing that process control block information, CPU will start executing the process. Okay, you can in general terms to say that if you are running a program, if the program finds if any method function call, so the control will shift from that place to the method. Okay, it will go there and executes that method. Okay, by seeing that written information, it will again go back and continue execution from which point it has left. Okay, that is in this way the CPU switches from one process to other process. Before shifting from one process to other process, the process which was currently running, that process information must be saved to the process control block of that process. Okay, Here you can see the process P0's information is first saved to the process control block of 0. Okay, then it will load the state information of process control block 1. From there it will load the process P1's information. Then from that it will start executes the process P1. Again, after execution completion, CPU will save the state information of the process P1 to the process control block 1. Okay, after that again it will reload the state information from the process control block 0. That is nothing but process control block 0 holds the information of process 0. Okay, it will reload the state information from the process control block 0. From that, using that information, CPU will start executing the process 0.